Chapter 2 Notes Video, Part 1. We are going to be reviewing a few things from Algebra 1, but depending on how long ago that was for you, some of this might feel new. So we're going to be talking about relations, domain and range, and functions. A relation is a set of pairs of input and output values. So a lot of times we're talking about functions, we're looking at equations where we have an input and an output, which are x and y. However, a relation doesn't have to be a function because a function is more restrictive. A relation is any sets of inputs and outputs. And we can display that in 4 different ways. Our first way is with ordered pairs. We're used to seeing these when we graph, where we have an x value and a y value displayed with parentheses around them. Our second way is by mapping. That's a list of inputs and a list of outputs with arrows showing going from an input to an output. It's called a mapping diagram. You might not have heard of that name before, but this idea of going from the input to the output you have seen before in an XY table, which is our third type of display of a relation. So an XY table has the X values or the inputs and the Y values, which are the outputs. And it's very, very similar to the ordered pairs, except with a different notation. It doesn't have the parentheses. And then our last method is with a graph that's set as a set of points. And again, those points can be represented by the ordered pairs, but this is a visual representation of them as a location. So the X and the Y value aren't given, it's just the point on a plane. So 4 different ways that we can represent relations. When we're given a relation, we can find what's called the domain and the range. The domain, or all of the X values, are the inputs, and we write them as a set. Set notation, we've talked about before, is like an E with the hiccups or a 3 with the hiccups. So you draw an E, but instead of drawing it normally, you hiccup. Or a 3, but instead of drawing it normally, you hiccup. And that makes our set notation. A set is like an opaque bag of items. You can't see into it always, but it's just, the order doesn't matter. They're all scrambled together. The thing you don't want to do though, is if you put the same thing in the bag twice, you only mention it one time. So a set, for example, is a list of numbers or letters. So I can say like ABC is the set, and then I put those curly brackets around it to represent that that's my list. When I'm listing the domain, I'm listing all of the inputs or the X values. A range is exactly the same. We're going to write it as a set or a list, but now it's the Y values. So I've given us a mapping here of inputs to outputs, and we want to first write that as a set of ordered pairs. So notice I already included our set brackets, and I'm going to list the ordered pairs here. Ordered pairs are always input comma output or X comma Y. So if my first input is 0, then the output is 10,000. Notice I didn't put a comma on 10,000 because I already have a comma as part of my ordered pairs. If I put a comma on the 10,000, that's going to be confusing because it will look like an ordered triple. We'd have 0, 10, 0, 0, 0. How do I know which comma is for the ordered pair and which comma is for the value? So when we have something in the thousands or even bigger than that, we do not put commas for the place values. My next input is 4. So I'll put a comma, and then my next ordered pair, 4 with the output of 9,744, again without a comma. And then separating ordered pairs, I put a comma. My next input is 8. Output is 8,976. So my next ordered pair is 12, 7696. And then my last ordered pair is 16, 5,904. And that makes up my entire set of ordered pairs. For the domain, I'm taking only the X values. So I'm underlining them here. The X values or the input values go into my domain. That's 0, 4, 8, 12, and 16. I make sure none of those are repeating, and that's my final domain. I'm going to do the exact same thing with my range. So my range are my Y values. Those are 10,000, 9,744, 8,976, 7,696, and 5,904. Notice again, within the numbers, I did not include the commas. The commas separate the values of my range. Domain was the inputs, the range are the outputs. I don't have any repeating values, so I don't have to worry about cleaning up my sets. I'd like you to try an example. I have given you a set of ordered pairs, and I'd like you to find the domain and range of this relation. Go ahead and try that, and then I'll give you the answer. Okay, so hopefully you've had a chance to find that the domain is all of the X values. That's -3, 0, 2, 9, and 23. No repeats, so I don't have to simplify that. If there was a repeat, I would just rewrite the set without the repeat. For the range, I have 14, 7, 0, -18, and -99. So that's our domain and range. Now, none of my X values repeated. And what that means is that this relation is actually something special, and that's called a function. So a function is when we have a relation where the X values don't repeat. Another way of saying that is that the domain corresponds with exactly one element of the range. X values are only used one time. The input value is used at most one time. Okay, now algebraically, we can see this if our X values repeat in our ordered pair, in our XY chart, or in our mapping, if there's more than one arrow pointing away from an input value. Graphically, how we see that, and this is the way we're used to talking about functions, is with the vertical line test. The vertical line test says that if I can draw a vertical line and it passes through more than one point, then that relation is not a function. So if we're looking at these examples, in example A, I can draw a vertical line and go through only one point. So I can draw a vertical line, but the question is, can I draw a vertical line through 2 or more points? And I can draw a vertical line that goes through 2 points. As long as I can draw one vertical line that goes through more than 1 point, then it's not a function. As long as I can draw a vertical line that goes through more than 1 point, then it is not a function. So A, not a function. B, I can draw a vertical line through every point, and it only goes through that 1 point. So this is a function. Take a second to look at graph C. Do you think that's a function? If we draw vertical lines, no matter how many vertical lines we draw, they will only ever go through 1 point. So C is a function. If we can define functions graphically, we can also define functions algebraically. That's where equations come in. So when we're drawing an equation, we usually say y equals something with an x. And since we're setting y equal to something with an x, we can say that y is a function of x, or y equals f of x. This is like nicknames. So depending on who is calling me by name, they might call me something different. For example, at school, I'm Miss Yang. At home, I'm Michelle. With my nephew, I'm Auntie Shell. So I have different names. This equation also has different names. Sometimes it's called y, sometimes it's called f of x. And then we have a use for the function. So just like we were doing in our last chapter, sometimes I'll ask you to evaluate an expression and I'll give you a value to substitute in. Now we have a shorthand for that, and that is f of a value. So when I say f of 1, that means let x equal 1. Notice the 1 is in the same place that the x was. So we're giving you, this is a shorthand for let x equal 1. It's just a short way of writing the instructions. Since all of this revolves around x, x is called our independent variable. I can choose a different x and then y will change with it. So x is the independent variable and y depends on x. So we call it the dependent variable. Y, also called f of x, is called the dependent variable. So let's look at an example. In this example, I have given you an equation and I gave you some inputs. I'm going to do the first one and then I would like you to try the next two. So for a function f of x equals -2x plus 5, we want to find the output if our input is -3, 0, and 1/4. So let's try -3 together. X is -3, so f of x will be f of -3. That means anywhere that there's an x, I put -3. It's a substitution. -2 times x, which is now -3, plus 5. Order of operations, I do -2 times -3, which is 6, plus 5 is 11. So my output is 11. I put -3 into the equation, and I get 11 as my output. That means my ordered pair is -3, 11. Okay, I'd like you to try 0. I'll get you started. This is going to be f of 0. And you're going to substitute 0 for x. You'll get an output, and then I want you to try writing that as an ordered pair. And then I'll check in with you before you try the 1/4. So when we substitute 0 for x, we get -2 times 0, which is 0, plus 5, giving me an output of 5 and an ordered pair of 0, 5. Go ahead and try the 1/4. Okay, so once again, we're finding f of our x value. So that's f of 1/4. Substituting 1/4 in for x, we end up with fractions. -2 times 1/4 is -2/4 or -1/2. In order to add 5, I need a common denominator. So I change the 5 into 10 halves. So if I have -1/2 and 10 halves, that's 9 halves. So this is 10 minus 1 halves, giving me 9 halves. Okay, now I'd like you to try the second example here for a different function. Notice it changed for all 3 values. Checking in on a equals to -2, you should get an output value of 9 and an ordered pair of -2, 9. For an x value of 0 or an input value of 0, we get an output value of 1. And for an input value of 5, we get an output value of -19. Okay. That's where we're going to stop today. And your homework is on Math Excel.